Hello and welcome back to another episode of Low Spec Labs. Once again, thank you for hitting the like button if you actually like this content. Thank you for the comments and thank you for hitting subscribe. If you're new to the channel and you'd like to keep up with it, go ahead and hit the subscribe button. Otherwise, let's get started. We're in chapter 12 of Sander Van Voigt's RHCSA EX200. This chapter is about scheduling Linux tasks. So basically automating processes so they go off at specific times. That'd be pretty useful to know, wouldn't it? You know, if you could have your server do things at a time when you needed them to do them. Sounds useful. Let's learn how to do that. There are two main utilities used to schedule tasks on Red Hat based systems. Those utilities are systemd timers and cron. Systemd timers is the newer of the two, and cron is the legacy. It goes way back, older than I. Let's talk about systemd timers. So one of the reasons people on Linux don't like systemd is because it's more than an init system. It's slowly been taking over a bunch of different legacy services and adding a bunch of extended functionality. Is this good or bad? Depends on which way you feel about what should be a modular system slowly losing modular functionality. But that is a rabbit hole, one we don't have time to currently pursue. Let's talk about systemd timers instead. Just like systemd unit files define systemd services, systemd timer files define when those systemd services start. So your unit file defines your service. Your timer files define the times when those services will start. Let's look at a timer file as an example. If we were to do a nano user lib system log rotate.timer, you'd see we have a file that looks very much like a unit file, but the layout is slightly different, right? So it says daily rotation of log files. One of the main things we'll notice that's different here is that instead of it saying service or instead of it saying target, it says timer. And then right here you can see when the timer starts, it's daily, on the hour, and persistent basically means, you know, we keep running this. It even tells us the target we want, which is timers.target. Let me clarify this RHCSA portion here a little bit more. So on calendar day defines how often this script should run. So basically how many days we should wait since the last occurrence for it to run. RHCSA defines the time intervals it should run. So technically this script should be running every day, and then it should be running once an hour every day. If we wanted to change when this script should run, we can actually change this value to a bunch of different values. Let's walk through some of them real quick. We've talked about RHCSA, but there's actually another one. Another value is on active set. And what this value does is basically it immediately starts the counter. So it counts. What this value does is immediately starts a counter from the moment you set that value inside of the timer. So if we were to set this to 1 hour and, you know, uncomment that configuration value, the script would look at when the last time it was run and then start a counter down from that moment. So it would check itself and run itself every hour or 5 minutes or 30 seconds or whatever we set it to. The next value is on boot set, and that starts a timer from the moment you boot the machine up. The next value is on startup set, which is basically from the moment systemctl starts. So it's different from boot because by the time you get to systemctl, you're technically already booted. Next is on unit active set, and that is another timer that basically starts the timer from the last time the service was started. So let's say we wanted to start SSHD. The timer would start technically from the last time we started SSHD. And the last one is on calendar day. And what that one does is basically sets the service to start on a specific day. So let's say we wanted to start on May 3rd, the 22nd, because we hadn't checked in a while. It would do that. Very useful. Now that we know how timer files are set up, how do we manage them? Well, let's walk through a little lab in practice. Do you recall the systemctl list units command from a video or two ago? I hope so. It's going to be popping up again. And then for us to view unit types of the type timer, or for us to view timer configuration files, we would do systemctl list units -t timer. There we go. And as you can see, these are our current timer units right here. And these are the ones that are currently loaded and active. What if we wanted to find all the timer files that reference logs? We could do systemctl list unit files, and then we would actually search for the unit file. So we could do star log star, and it would list all the unit files that contain the word log. So you can see these are various different unit files here. So we just searched for the unit file we wanted to find, and we found log rotate.timer. We want to quickly look at that. How do we do that? We do systemctl cat, and then we can just do log rotate.timer. And then we can just see the contents of that log file. No need for us to actually, type in the entire path like we've been doing for the past couple of videos. And then if we wanted to check the status of that service, we would do systemctl status log rotate.service. And as you can see, the status is dead, so it's not currently active. Well, the service is dead. That might be because it's on a timer. So let's check that timer. So we could do systemctl status log rotate.timer, and you'll see the timer is active and waiting, but the service itself is dead. So basically the service is in a disabled state until this timer is active, and then it's going to be enabled, do its thing, and then re-disabled. Let's try something out. Let's do dnf install -y sysstat. Cool. Now let's see what unit files got installed with that application we just installed. So to do that, we can do systemctl list unit files sysstat. As you can see, it lists all the unit files that got installed when we installed that new application. For instance, we have sysstat.summary, sysstat collector.timer, which are timers that automatically start these services. We even got the sysstat.service unit file installed as well. And last but not least, what if we wanted to look at that timer file to see what it's doing? Well, we could do systemctl cat sysstat. Well, we could do systemctl cat sysstat.collector.timer. I see. Added an extra R there. And there you go. It gives us the output of sysstat collector. As you can see, it says system activity accounting for every tool every 10 minutes. And then it gives us an on calendar day. So useful stuff there. Systemctl timer is the new utility to automate Linux tasks. It's somewhat unfamiliar to me. The old utility to automate Linux tasks was called cron-d, which is far more familiar because that's available on many Linux distros. Let's go ahead and find out how to use it. Here we have systemctl status cron-d. So you can see the cron daemon, and it's set to run hourly or every minute. There's a few different services when it comes to cron. When scheduling services through cron, you need to specify when exactly you want that service to run. How do we know how to schedule a service through cron? Well, to do that, we'd have to look at the cron configuration file, which is located at etc cron tab. Let's do a cat of etc cron tab and see what it outputs. And when we cat etc cron tab, it gives us an example of a cron tab output and what it means. So let's break this down a little bit more. Looking at your cron tab file, you'll see that it's represented by 5 dots. These 5 dots represent however many minutes you want the cron tab to run, however many hours, on what day of the month, on what day of the month itself, or like the actual month, and then what day of the week, right? So with these, you actually have a very versatile way for you to define a cron tab, or define a specific time you want a task or command to run on your system. You would think for you to manage cron tab, you would edit etc cron tab, While that technically works, that's not the considered best practice. Instead, there are several different methods. The first is to use cron tab-e, which is for user-specific cron tab scripts. Let's see what happens when we use that command. So we can do cron tab-e, and you'll see it opens up a VI file. And here we can edit cron tab files, set a script to run, and then those scripts would apply to our specific user, which in this case would be the root user. The second is to put cron files in etc cron-d. So we would make a cron file formatted like that, and then we would put it in etc cron tab or cron.d. As you can see, we have a folder called hourly, and then when we cat that, you can see we actually have a cron file that runs every hour, right? And that's basically a mail job. And you can see right there, the first setting is for every hour. Let's run in ls/etc and then look for entries that say cron. As you can see, we have all these folders: cron d, cron daily, cron deny, cron hourly, cron monthly, the actual cron tab folder, and then cron weekly. These folders right here is where you would place scripts as you needed them to run. So if you had a script you wanted to run every day, you would set it in cron.daily. If you needed to run every hour, you would set it in cron.hourly, etc., etc. If we're going to talk about cron, we should also talk about anacron. What is anacron? Anacron is the background service that cron uses to run its scheduled tasks and jobs. Let's look at anacron a little bit more. I ran ahead and ran a cat etc anacron tab so you could see the configuration file of anacron. Anacron basically just runs those cron jobs that we have in those cron folders, and it does that automatically. And that's it for scheduling Linux tasks. This was a shorter chapter than I anticipated. It would seem we only had really 2 topics to cover, which was systemctld, which is the primary focus of this chapter, and then there's cron, which is the secondary focus. So thank you for watching and tuning in.